Today we're going to go over solving quadratics. And so we've done solving by factoring already, so let's quickly review that. When we are solving a quadratic and we do that by factoring, we get it set equal to 0. And so remember that when we're solving, we're also looking for those roots. So we're getting it set equal to 0, so we find that x-intercept. We then factor the trinomial and set each one of the factors equal to 0, because that's x minus your first root, x minus your second root. We get 3 and 1. That is one way of factoring, of solving for a quadratic. Another way of solving for a quadratic is the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. You probably learned that as a song in Algebra 1, but this is the formula for solving a quadratic. In the standard form, which is the ax squared plus bx plus c, I'll go ahead and write that up here. The a value is the coefficient of x squared. So negative 4 would be our a value here. The b value is the coefficient of x. So that's negative 40 there. And the c value is the constant at the end there, so that is negative 99. Once we have the a, the b, and the c, we are going to substitute that in for a, b, and c in our formula. Notice that we use parentheses to enter each one. That keeps you from making errors and sign issues. So you always want to put the parentheses instead of the b. We put a parentheses and we place exactly what we had for b in that parentheses. We then start to simplify. So 40 squared gave us a 1600, and negative 4, and negative 99 gave me this negative 1584. We combine it and we get square root of 16. The square root of 16 is 4. And then that little plus or minus is what happens next. That's where we then separate that and do 40 plus 4 and 40 minus 4. And then we finish separating that to get our two x values, negative 5.5 and negative 4.5. So we are going to do one of each here. And the book forgot the little square there. That should be a square right there. All right, so we are going to do this first one with the quadratic formula. And so I get x equals negative, and in the place of b, I'm going to put a parentheses, plus or minus the square root of b squared. So I'm going to put a parentheses for b again, minus 4 times a, so I put a parentheses there, times c, all over 2 times a. So I've replaced a, b, and c with the parentheses. And this is where we start filling it in with the a and the b and the c up here. So this one is the b. The b is the coefficient on x. So there it is right there at negative 3. So I'm going to put that in the place of the b's. I then need a here. The a is negative 2, so I'm going to put that in the place of a. And the c is 7, so I put that in the place of 7. And so I start to simplify. A negative negative turns that into a positive 3. Negative 3 squared is 9, because that's negative 3 times negative 3. And then negative 4 times negative 2 times 7 is 56. In the denominator, we have 2 times negative 2, which is negative 4. Now we continue to simplify, and you really want to go step by step so that you don't make an error in calculation. So that would be the square root of 65 and then negative 4 on the bottom. That is a perfectly good answer for the quadratic formula, because the square root of 65 does not simplify any further, so we can leave it like that. All right, for B, I'll go ahead and review factoring. When you look at the trinomial, you want to check first if it factors, because that is easier than the quadratic formula. So when I look at these, I say, can I find something that factors? So I look for what multiplies to be negative 24 and adds to be this negative 5. And so x times x would give me the x squared. And what multiplies to be negative 24 and adds to be negative 5 is negative 8 and positive 3. And so this is x minus your first root and x minus your second root. So we know that the root is 8 and negative 3. Or you can take each one and set it equal to 0 and solve. So you would add 8 here and you would subtract 3 here. So there is our two roots. So let's talk about our solutions there on a quadratic. We said the solutions is where it crosses the x-axis because we get the equation set equal to 0. So in this case, we have two solutions, one right here at negative 2, 0, and one at positive 2, 0. This one too has two solutions. When your vertex happens to be on the x-axis, then the vertex is the solution, and you've got 1 in that case. And when the quadratic does not cross the x-axis, then it has two complex solutions, or imaginary ones. So here are our options. 2 real, when it crosses in 2 places. 1 real, when it crosses the x-axis only 1 time. And then when it does not cross the x-axis, then we have 2 complex or imaginary solutions. So we are going to now look at the equations from some of these to see what exactly is happening. In this first group here, we have x squared minus 4. And so we want to do the quadratic formula here, and we get negative b plus or minus the square root b squared minus 4ac all over 2a. So the first thing I do is substitute those parentheses. Now I'm going to go ahead and put in the information from our equation. My b value comes from whatever's in front of the x, which is not here. So we know that that is 0. My a value comes from whatever's in front of the x squared. Our coefficient there is 1. And our c value is the constant, which in this case is negative 4. So now we simplify. Negative 0 is just 0. We don't even have to write that. And we get the square root. That's 0. And negative 4 times negative 4 gives us a positive 16. And 2 times 1 is 2. Now the square root of 16 is 4. So we can simplify that further. And that is over 2. And so this is where we can separate it into the 2. We get a positive 4 over 2 and a negative 4 over 2, which is 2 and negative 2. Notice that that was where our graph crossed, 2 and negative 2. So you can look at the graph and see where the solutions are there, 2 and negative 2, or you can look at our quadratic formula, plug it in, and go all the way to the end. All right, so we'll do another one here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So we plug in our negative 6 for our b because that's what's in front of the x. I plug in a negative 1 for my a, and I plug in a 0 for my c since that's not there. And now we start to simplify. A negative negative becomes a positive 6 plus or minus 36 plus 4 all over negative 2. Last class we did practice simplifying these radicals, so you should be able to simplify this further. The biggest perfect square that goes into 40 is 4, so 4 times 10 gives us 40. The square root of 4 is 2, so we get 2 root 10 over negative 2. Now, negative 2 does go into both of those, so I can simplify this one step further. 6 divided by negative 2 is negative 3, plus or minus. 2 divided by 2 is 1, so that is 1 root 10. And so this is our root there. You could get a decimal approximation to see where it matches up on the graph, but that's a perfectly good answer there. All right, for this second group, B, we're going to go ahead and do our quadratic formula. And I always start by putting my parentheses there for A, B, and C to make sure I'm not making any mistakes. So in the place of B, I'm putting a -6. In the place of A, I'm putting a -1 because that's in front of the x squared, and my constant is -9. Now we start to simplify. That gives me a +6 there because negative times a negative. In the parentheses here, I get 36 minus 36 over -2. When I take this one step further to simplify, I end up with a 0 under the square root. The square root of 0 is 0. And whether we add 0 or subtract 0 is not going to change anything. So this is going to end up being 6 over -2, which is -3. So now we only have one solution. So back to those graphs from group B, we only had one solution right here at -3. That's where the vertex was. So here we see that when we ended up with 0 under the square root, it only gave us one solution. When we had the number under the square root, we ended up with 2. Even in this case where it looks like 1, it's 2 because it's -3 plus the square root of 10 and -3 minus the square root of 10. All right, now we're going to look at our C ones. And so I get x equals -b plus or minus the square root b squared minus 4ac all over 2a. I start to plug in my values. -12 is my b, 2 is my a, and 19 is my constant. And so we start to simplify this now, and a negative times a negative gives me a +12. Under the square root here, we end up with 144 minus 152, and 2 times 2 is 4. And so here we get 12 plus or minus the square root of -8 over 4. So now we've got a negative under the square root. Well, we learned how to simplify negatives last time. Remember, the square root of -1 is I. So we are going to need an I here. And so I get 12 plus or minus, and the biggest perfect square that goes into 8 is 4. 4 times 2 is 8. So the square root of 4 is 2. We need an I for the negative, and 2 is left. If you need a tree for that, you can make the little tree and figure that out as well, but you've got to get those radicals simplified. Now we can simplify this further. These can be reduced by 2, all of them, so I reduce it by 2, so that's 6 plus or minus I root 2 over 2. That is a perfectly good answer right there, so that would be my root. It is an imaginary root since there's that I. And so if we go back to our graphs here, we see that in this case, the one that we just did, it did not cross the x-axis. That's the reason why we had the imaginary number. Now, if you look at this equation to see what happened to give us that imaginary number, it was this negative right here under the square root. So under the square root, we saw when it became a negative, it gave me an imaginary solution. When it was 0, it gave me one solution. And when it was a positive number, it gave me 2 real solutions. So that part under the square root is a pretty important part because it gives us a lot of information just by looking at that part. So they've given it a name. It is called the discriminant. So that b squared minus 4ac is called the discriminant. It determines what kind of answers you're going to have and how many. So if that b squared minus 4ac was equal to a positive, then there were 2 real solutions. And that graph looked like this. It hit in 2 places. if b squared minus 4ac was equal to 0, then there was one real solution. And that graph was the one with the vertex on the x-axis. And then our last one, b squared minus 4ac, when it was equal to a negative, there were two complex solutions, or imaginary. And that was when our graph did not touch the x-axis. So those are the three options. You will get questions that sometimes just ask how many solutions and what type of solutions, and that's where you would just want to do the b squared minus 4ac. So under the radical, if it's positive, you're going to have two real. Under the radical, if you have a 0, there's going to be one real. And if it is a negative under the radical, you will have two complex solutions. All right, so the questions that say use any method to determine whether each function has real or imaginary zeros, this is where we would want to use that discriminant. So I would set up my b squared minus 4ac. And so I set up my parentheses, b squared minus 4ac. My b value here is 2. So I'm going to plug that in for the b. My a value is -3. So I'm going to plug that in for the a. And my c value is -1. That gives me 4 minus 12, which is equal to -8. So my answer here would be two complex solutions. Because the discriminant is negative, I know it's two complex solutions. All right, so here we set up our b squared minus 4ac. And so my b value is 1, my a value is -1/2, and my c value is -1/2. I simplify this and get 1 minus 1, which is 0. That would be one real solution. We said when our discriminant is equal to 0, it is one real solution. And for my last one here, I plug in -5 for the b, 2 for the a, and -6 for the c. And so -5 squared is 25. -4 times 2 times -6 is 48. I add those together and we get 73. And so that would be two real solutions. So by looking at that discriminant, you can determine how many solutions you have. All right, on the next page of your notes, you do have some in a different format, the standard form. It's not in the standard form, it's in the vertex form. You can also determine how many solutions there's going to be from that form if you think about the characteristics. So looking at this one right here, it is in the vertex form. The vertex form gives us the vertex, which in this case would be 3 and -4. It also gives us our concavity. Because it's negative, we know it's going to be concave down. So if I sketch a quick little picture here, 3, -4 is over here. And if it is concave down, that is not going to touch the x-axis, so I could say two complex solutions. So just because it's not in the standard form doesn't mean you can't determine those, whether it's complex solutions or real ones. Here is a second one. We have 2x minus 3 squared minus 4. Our vertex is at 3, -4. And it is concave up there. So if we sketch a quick picture, we've got 3, -4. And then it is concave up. So in this case, it will touch in two places. So we would have two real solutions. In this last one here, again in vertex form, our vertex is 3, 0. As soon as I see that 0 there, I know that's a root. So that has to be right here. Whether it opens up or down isn't going to change anything. That vertex is on the x-axis, so that's going to be one real solution. Now below that on your notes here is a chart. You want to make sure you go through this chart and read it and understand it. It gives you a lot of different pieces of information all in one place, all of the things that we've talked about. So it talks about the factored and the vertex and the standard form. It tells you how to determine what kind of solutions they are. It also gives you information on the imaginary zeros as well. So that's a good chart to reference back to. The last thing we're going to do is talk about writing equations from the imaginary roots, because we have talked that the factored form is a times x minus r1, x minus r2. This is the factored form, and we've written equations with the real roots. We've plugged those into here and multiplied it out and got the standard form. That could be done with the imaginary roots as well. If we've got a root at 5i, we know that comes from that plus or minus, so then we also know that there is a root at negative 5i. So these are the two roots for this quadratic. So we can take this and do x minus 5i and x plus 5i. All I did was plug this into here. If no other information is given, we can assume that the a value is 1. If they give you another point, then you have to find that a value. But if no other information is given, then you can assume a is 1. And so we do x minus our first root, x minus our second, and that's where we got this. And then last class, we learned how to multiply that out. You FOIL or use the box. So x times x gives us x squared. X times 5i gives us 5xi. Negative 5i times x gives us a negative 5xi. And negative 5i times positive 5i gives us a negative 25i squared. These two are going to cancel because they have opposite signs. And then I squared, I told you had to know that one, I squared is negative 1, and negative 1 times negative 25 gives us a positive 25. So there is our equation for the imaginary roots. Keep in mind that we've never given you a quadratic that has i's in it. So when you finish your answer, it should not have any i's in it. So you do have to remember that I squared is equal to negative 1. Now these will challenge your algebra skills. So I'm going to go ahead and show you another one that's a little bit more challenging. If we have the root 3 minus I, again, you know that then you have the one that is 3 plus I, because it's always that plus or minus there. And so we get x minus my first root, which is 3 minus I. And then x minus my second root, which is 3 plus I. Now, just like the other one, you're going to have to FOIL this. And the easiest way to FOIL this is to get rid of the parentheses on the inside first. So I'm going to do that first, and I get x minus 3 plus I in the first parentheses, and then x minus 3 minus I in the second parentheses. If you do a box, you can do a 3 by 3 box to FOIL this out. If you just distribute, which is what I'm going to do here, I multiply this x times everything in the other parentheses. So x times x gives me x squared, x times negative 3 gives me a negative 3x, and x times a negative I gives me a negative xi. Now I distribute this negative 3, so I multiply this negative 3 times everything in there, and so I get negative 3 times negative 3, which gives me a positive 9. Negative 3 times x, sorry, I forgot that one, would be a negative 3x, and negative 3 times negative I gives me a positive 3i. Now we distribute the I times x gives me xi, I times negative 3 gives me a negative 3i, and I times a negative I gives me a negative I squared. That's the harder part, just to get all of that distributed. Now a lot of this will cancel out. 3i and negative 3i cancel because those are both the same with different signs. Negative xi and positive xi cancel because those are both the same sign. So we can start combining some of our like terms. We've got a negative 3x and a negative 3x. That gives me negative 6x. And then what's left is a 9 and a negative I squared. Remember, I squared is negative 1. So this turns into a positive 1, and 9 gives me 10. There is our quadratic equation. got one left. And so here we start our equation again with x minus my first root, which is 2 plus 3i, x minus my second equation, which is 2 minus 3i. And now we're ready to distribute that negative to everything in there. So that gives me x minus 2 minus 3i. On this one, we get x minus 2 plus 3i. And now we start that multiplication. So you got to make sure that you're keeping track. Don't try and skip steps. Makes it much easier if you're lining up your work clearly. So x times x is x squared. X times negative 2 is negative 2x. X times 3i gives me a 3xi. Now we distribute the 2. Negative 2 times x gives me negative 2x. Negative 2 times negative 2 gives me a positive 4. Negative 2 times 3i gives me a negative 6i. Negative 3i times x gives me a negative 3xi. Negative 3i times negative 2 gives us a positive 6i. And a negative 3i times a positive 3i gives us a negative 9i squared. Once you have those all written out, it's time to start canceling the stuff that's going to cancel. We've got a 3xi and a negative 3xi. We have a negative 6i and a positive 6i. And if the stuff doesn't cancel, you're going to want to think through that to make sure that you've done it correctly, because you should never have an I in your final statement. Now we start combining our like terms. The negative 2x and the negative 2x give us a negative 4x. And then we've got 4 plus 9, because that I squared is negative 1, which is 13. There's our final equation.